Hello everyone, thanks for joining me in this course. Advanced Android is about helping you understand what it means to have good application architecture. There are several key items we will cover, including MVVM and MVP architecture, dependency injection with Dagger 2, and reactive programming with RxJava. In this video, I'm going to quickly go over the main points that the course will cover. We will dive heavily into one way to architect an Android app and why the steps we take are important for a potentially large application. We will use Dagger 2 with a 3-level scope hierarchy to handle dependency injection. Reactive programming with RxJava 2 and related libraries will be used throughout the app. For network requests, we will rely on retrofit. Getting into testing, we will have expansive unit tests where possible. And for each of our screens, we will look at UI testing with Espresso and how Dagger 2 can make this easier. With Model View Presenter, you have these 3 distinct layers. This is probably one of the most common software architecture patterns you'll hear about, and for good reason. It allows a nice separation of responsibilities, making testing and maintaining your code much easier. Following the arrows, you see how the presenter is the glue between the model and view layers. Communication from the model goes through the presenter, who then passes it to the view, possibly after some manipulation to get the data the view layer needs. User events are passed from the view to the presenter and possibly trigger changes in the model, which can start the flow all over again. This is a perfectly suitable architecture for Android applications, though I find it has some shortcomings. The presenter needs a reference to the view, and this can be an issue because it is a point for a potential memory leak. As the view layer in Android is ephemeral, it may be destroyed and recreated at any time. Sure, with proper logic this can be handled relatively safely, but we can do better. Taking MVP as our starting point, we add a new layer called the view model. We still retain the presenter as I feel it can serve a distinct purpose, which we'll see in the course. At first glance, this may look more complicated, but this interpretation of MVVM has many benefits. Notice there are no arrowheads on the connection between the view and the view model, and this was done on purpose to indicate that the view model has no reference to the view. Data is passed from the view model to the view using observables that the view subscribes to. In fact, no other object in this architecture has a reference to the view. This removes a potential point for memory leaks, and since data transfer to the view is reactive, we can update the view model even when the view isn't listening. Once the view subscribes to the view model, it will retrieve the latest data. The model can be updated by either the presenter or the view model. I have both of these outlined because again it comes down to what makes most sense for your use case, and this will be more clear once we get into coding. We will make heavy use of Dagger to organize our dependencies. Using scopes, we will be able to have dependencies shared at different levels, but also have specific ones for lower scopes that can be discarded when those scopes are no longer needed. This graphic shows an example of how scopes are related. Starting with our base scope, called the application scope and represented by the singleton annotation, we can build layers to provide a branching object graph of dependencies. Adding the activity scope, which has access to all dependencies provided by the application scope, is the next step. There can be multiple activities that each have their own scope and independent dependencies. However, they will all have access to the same dependencies provided by the application scope. Our last scope will be the screen scope. This is built on top of the activity scope and just like before can define its own dependencies but also have access to all the dependencies provided by the application scope and the activity scope which it's built on top of. This method of dependency management is very powerful, and while it may seem difficult to grasp at first, I'm confident once you understand how these object graphs of dependencies are built, you'll have a much easier time managing a large application. Finally, we come to reactive view models. This graphic shows an overview of how they work. In short, data is exposed to the view layer via observables. This allows us to never have to have a reference to the view in any of our other layers, which is a huge boon to Android development. View instances can come and go, but our view model will remain waiting. That is, until its scope is destroyed. I'm extremely passionate about software architecture, and I'm excited to be able to teach you the concepts to allow you to create large, maintainable, and testable Android applications. See you in class.